Okay guys, so now we are almost at the end of this semester. Let's try to focus on this section 5.1, inverse functions. And you have to remember that if you want to know if two functions are inverse to each other, first of all, these two functions is to be one-to-one. Okay, so what does that mean to have two functions are one-to-one? Well, basically, if you have two numbers, two different than 3, that implies that f of 2 will be different than f of 3. Okay? And of course, this definition is kind of quite difficult to use, so we are going to use another methodology to determine the one-to-oneness, and it's about the horizontal line test. Okay? So what is the horizontal line test states? The horizontal line test states, difficult to pronounce that, right? That is, an horizontal line intersect a graph more than one time, that function is not a one-to-one function. Okay, so if your horizontal line intersect a graph more than one time, that function is not a one-to-one function. All right? So that is very important for you to remember what is a one-to-one function, and how do we define if my one-to-one function is if my function is a one-to-one function. All right. Now, let's try to figure out about the inverse of a function. Well, it's very, very, very easy, guys. To find the inverse of a function, you are going to substitute the value of x by y and the value of y by x. Let's try to look at the example number 1, and we will go back to specifically what the example number 1 is telling us, okay? But I want to almost jump on what you are going to have to deal with. So you have a function f of x equal 3x plus 5, okay? So we have a function, and this function is f of x equal 3x plus 5. If I want to find the inverse of this function, knowing that this function is a one-to-one function, because if it was not a one-to-one function, I will be not able to. So this function is a one-to-one function, and I want to find the inverse. Right now, what do I have is y equal 3x plus 5. To find the inverse, okay, what you are going to do is very simple. What was x is y, and what was y is going to become x. So to find the inverse of your function, you are going to change x in y and y in x. So it's going to become x equal 3y plus 5. And now, to find the inverse, you just need to isolate y, and you are going to subtract by negative 5 both sides. You end up to have x minus 5 equal 3y. You divide by 3 both sides, and you end up to have an expression of y equal x, let me do that again, x minus 5 divided by 3. And that is, ladies and gentlemen, the expression of your inverse function. If I want to write the function in another way, I would have y equal 1 over 3x minus 5 divided by 3. Now, we know how to calculate and how to express, should I say, the inverse of your function f of x. I want to go back to this, because how do we know when you have two functions, and how do we say if these two functions are inverse to each other? Well, if these two functions are inverse to each other, we are going to calculate the composition of these two functions. So we are going to calculate f of g of x, and we know that it's going to be equal to f of g of x. Let's pretend that the function g of x, we don't know if it's the inverse of f of x. And let's try to compose these two functions to each other. And what's going to happen is going to be amazing, because we end up to have, when we compose both directions, we end up to have that the answer is going to be equal to x. And if I do in the other direction, g of f of x equal g of f of x, I end up to have also x. And ladies and gentlemen, every time you have two functions and you compose this function in both directions and you end up to have equal to x, that means these two functions are inverse to each other. I'd like to remind you that when we try to find and we try to pretend that we didn't know what was the expression of your inverse of the function, we end up to have the same thing, all right? So you have different possibility to find the inverse of your function, and that is a good way. It's a good thing because during the final exam or during the exam, you will have different way to check your answers, all right? So let's try to find the inverse of f of x equal 2x over x minus 5. Well, y equal 2x over x minus 5, and then I need to do is what was x becomes y, what was y become x. So I end up to have x equal 2y divided by y minus 5. And I need to isolate y. For that, I have to deal with a rational equation, and I know that I need to multiply by my LCD. What is my LCD in that case? My LCD is going to be y minus 5, right? Because when I try to find the LCD, I completely factorize each denominator into prime, and in that case, I have only one denominator, y minus 5, the other equal to 1, doesn't change anything, and so I multiply by y minus 5 both sides. When I do so, I end up to have y minus 5 times x equal to y, because on this side y minus 5 disappear, and that's why we are multiplying by the LCD to get rid of the denominator. What I'm going to do now is I'm going to distribute and then try to combine like term. I'm going to end up to have yx minus 5x equal to y. I'm going to move the term with y, all the term with y on one side, so I'm going to subtract minus yx both sides, and up to have negative 5x equal 2y minus yx. I factorize y, so 2 minus x equal negative 5x, and then I just need to divide by 2 minus x. I divide by 2 minus x, and so I end up to have the expression y equal negative 5x over 2 minus x. Okay, and that is the inverse of your function f of x. Okay, so you take a look at the example number 4. It is exactly the same idea. I'll let you take a look also to the rest of the problem, because I think it's pretty easy. Let me maybe try to do the example A. If I want to know if the function f of x and g of x are inverse to each other, well, I'm going to do it's pretty simple. I'm going to calculate f of g of x, and then I will have to calculate g of f of x. And when I do so, what do I have? It's very simple. What was x is going to be substituted by g of x. So I'm going to have cubic root of x plus 1 to the cube minus 1, which is going to be x plus 1 minus 1, and that's going to be equal to x. And if I do the other one, let me use another color. I'm going to use the green one. Okay? What I want to do is calculate g, not f, already done g, f. So g of f of x equal, and now I'm going to substitute inside g the x by the f of x, and so I'm going to have a cubic root of x cubed minus 1 plus 1. That is a cubic root of x cubed plus 1 minus 1 minus 1 plus 1, and that is going to be the cubic root of x cubed, which is going to be x. So yes, they are inverse to each other. Okay, so I'll let you do that on your own. Same thing for example number 3 and the different case A, B, C, D, and E, as well as F. Take your time, practice. We will talk about that in class. Actually, you know what? I still have a few minutes to spare in this video, and I'm going to calculate f of minus 1 for the minus square root of x minus 2. So if I want to calculate this one for you guys, and don't forget, everything, now you should know, but every single example I've done or you have to do needs to be on your note. Well, I'm going to calculate f of minus 1. So right now I have, let me erase that. Right now I have y equal negative square root of x minus 2. So I'm going to substitute the y by x and the x by y. Negative y minus 2. I need to put my negative x right here. So I have y minus 2 like that. I need to divide by negative 1, so now I get negative x. I'm going to take the square, both sides, because I need to get rid of the square root to have access to the variable y. Now what I got is a y minus 2 equal x squared, and so y equal 2 plus x squared. Why? Because I add to both sides in order for me to have y standing by itself. Thank you guys, and work well, and see you in class to do a set of problems from your book, and hopefully you would not need to try to do practice problem home.